Alright, so this video is going to be part 2 of finding the distance from a point to a plane. Okay, we want to find the distance from the point 1, -2, 4 to the plane 3x plus 2y plus 6z equals 5. Alright, and to do that we're going to use our distance equation here, the absolute value of ax1 plus by1 plus cz1 plus d over the square root of a squared plus b squared plus c squared. Now, this is the more kind of drawn out form of the distance equation. It's not as compact as the other one that we did in the part 1 video. Okay, so this is if you really want to go ahead and memorize it just to make your life maybe a little bit easier, okay, because all you have to do now is just plug in. Okay, so now what we have to do is 3 things. We're going to find the normal vector, we're going to find d, and we're going to find, well, the point is actually given to us, so we know what x1, y1, and z1 are going to be. Okay, starting off, d, we're talking about the linear equation of a plane here, and that's what we were given. If we subtract 5 on both sides, we get our d, which is -5. Okay, our x1 is going to be 1, y1 is going to be -2, and z1 is going to be 4. Right, that's just talking about the point given to us in the problem. And lastly, we need to find a, b, and c. Okay, they're used not once but twice in the problem. Okay, so how do you find the normal vector? Well, it's just the coefficients on x, y, and z. Okay, it's going to be 3, 2, and 6. And now you literally, all you have to do is just plug right into this distance equation. So it is actually pretty nice. Okay, so you're going to have the absolute value of, you have an a, which we know to be 3, okay, because your normal vector is a comma b comma c. So you get 3 times x1 is going to be 1 plus b is 2 times your y1, which is -2, plus c, which is 6, times your z1, which is 4, and then you have plus d, which is -5. You're going to put that over the square root of a squared plus b squared plus c squared. A is 3, so we get a 3 squared, plus we have a b as 2, so 2 squared, and then our c is 6, we have 6 squared. Okay, and now, a little bit of algebra here. The distance is going to be equal to, we have a 3 minus 4, which is -1, plus 24 is going to be 23, and a -5 gives you 18. So you're going to have the absolute value of 18, which is 18 on the top. And 18 is going to be over, you have a 9 plus 4 is 13, plus you have a 36. So I got 9 plus 4 is 13, plus 36 is going to be 49. So you have the square root of 49, that's 7. Alright, almost lost it there, got it. So your distance is going to be 18 over 7. Okay, that's literally all you have to do. Now, if it were me, I don't know that I would have really remembered this whole distance formula, okay? I don't know that I really would have wanted to, okay? Because the component of, a vector onto another vector, that's something that you're going to have to remember for a test anyway. So, I mean, you already know that if you just put in, b and n, there you go, you have your component formula for the distance from a point to a plane. So, really, I mean, I would probably just go with that just because now you have less things to memorize. But, if this is easier for you, definitely go with it. Anyways, that's going to do it for this video. So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for vectors and the geometry of space in the next video in the series. Lastly, if these videos are really helping you and you would like to consider supporting me, I have my Patreon linked in the description down below, along with some other pretty cool links that you should definitely check out. See you soon.